the Hubble telescope on the left. Notice the Hubble telescope, its diameter is the spherical shape that fits in the spherical payload of the space shuttle. So now we want to put a bigger telescope into orbit. How do you do that? And so this is where you need engineers, clever engineers. We say, here's a rocket, one of the most powerful rockets we can use, but the fairing, that's the place where you hold the payload, can only be so big. And they say, all right, why don't we fold the telescope? Now, how are you going to fold the mirror? Turn the mirror into segments, hexagons. Hexagons, one of only 3 shapes that can tile a surface: a square, a triangle, and a hexagon. No other shape can do this. In the image there, what you can see is all of the mirror segments. Those fold into a narrow structure along with the unfurling solar panels, as well as the heat shields. Notice it was made at Northrop Grumman. By the way, Grumman has a long history in helping NASA put stuff in space. The LEM, Lunar Excursion Module, remember that? The thing that landed on the moon? That was designed and built in Bethpage, Long Island at Grumman Aerospace. And you slip that into a fairing, and then you launch it 1 million miles from Earth, opposite the sun from Earth, and it unfurls like petals of a flower. And it's specifically tuned for the infrared part of the spectrum. You remember the spectrum, so you have like visible light, right? Roy G. Biv, right? If you want to remember it, red, orange, yellow, green, blue, indigo, violet. Those are the parts of the spectrum we can see. But there's light outside of this. There's like beyond the violet, there's ultraviolet. That's how you get that. And below the red is infrared, not visible to the human eye. By the way, insects can see ultraviolet. We can't. That's why bug zappers work. You put a UV light in a bug zapper, the bugs say, oh my gosh, I love ultraviolet, and then they get zapped. And we're old enough to remember before there were bug zappers, you'd had a picnic bulb for twilight picnics, and it's like a yellow bulb, kind of yellow amber bulb. It was a bug bulb. It was sold as bug bulbs. It's not that they repelled bugs, it's that the bugs couldn't even see it, because their whole vision is shifted towards the ultraviolet. And it leaves out the deep red. Earliest forming galaxies in the universe radiated a lot of ultraviolet. So you might say, well, let's get an ultraviolet telescope. No, because 14 billion years later, the expansion of the universe has redshifted the ultraviolet into the infrared. So if you want to see the birth of galaxies, you got to know what they look like in the here and the now. And in the here and the now, it's in the infrared. So this is a telescope specifically tuned to see galaxies born at the edge of the universe. And infrared also allows you to see deep into gas clouds. People say the sun is yellow. No, it's not. It's white. If the sun were yellow, then in broad daylight, snow would be yellow. When the sun sets, its light is heavily attenuated by dust in the atmosphere. And in the Southwest, it's dust. Other places, it could be pollution or pollen. But these particles in the air scatter blue light out of the sun into the rest of the sky, turning the sky blue. And the more blue light it takes out, the more yellow-red the sun looks.
Right.
And that's why right on the horizon, the sun is its deepest yellow-red it will ever be. And people say, oh, there's our yellow star. No, the sun is white.
So it's just a newly discovered type of black hole.
So black hole shock theories swirl around the discovery of a physically impossible black hole. So scientists don't use the word impossible unless it's violating a known law of physics. So I bet that was an editor's title, and I don't have a problem. I don't mind a little bit of sensationalism there. You can say it is a black hole that comes from if it comes from an object, it is an object we know nothing about and have yet to discover. We're not going to say it's an impossible object. Every time we point the telescope to the universe, we find something that we never predicted or understood.
And it adds to the knowledge base they already have whenever they do discover things, and then it becomes what we know and understand, like the supermassive black holes at the center of every galaxy. That was a fairly recent discovery in terms of
it was
human
hypothesized
history.
because we saw the centers of galaxies were behaving really weirdly. Stars were moving faster than they should have, given how much gravity was tugging on them. And we said, dude, something's got to be there. And it's got to be really small because we're tracking stars really close to the middle. Well, if it was made of ordinary matter, how big it would have to be really, really big. So this has to be really, really small in order for this to happen. The only thing we know that could fill that small volume and have that much gravity is a black hole. So it was suspected for a long time. It was confirmed that as a common thing by the Hubble telescope and first photographed by this recent result in the galaxy M87. Messier 87. This is the pillars of creation, which were so named at the time Hubble first attempted this. We were gaga over the Hubble image of this. And now, like the JWST, oh my gosh. For those who are more prone to religion, some have called this the hand of God. Because if you look at the pillars, you can kind of picture like a thumb and fingers, yeah. So, but regardless, this is nearby. This is the telescope peering deep into gas clouds that otherwise would enshroud what's going on. And you get to see stars being born, planets being born. And so what's remarkable about JWST is that to be tuned for the edge of the universe and the birth of galaxies is the same properties you would want to see the birth of stars. A star is born right in front of your nose that would otherwise be cloaked by gas. And infrared penetrates those clouds and enables you to see it as though the cloud isn't even there. And you already know this because if you're driving through fog, okay, you put on your fog lights. The fog lights are not blue. They're like reddish, amber, okay? That improves your ability to see through the fog. If we could see infrared, that's the kind of light you'd use, then you wouldn't even know the fog was there. That's why self-driving cars will be amazing. It won't matter if it's foggy. They'll be able to see everything. Just give them infrared sensors. The fog is irrelevant. They can drive 100 miles an hour in dense fog, and all the cars will see each other. And they want to change lanes, they tell other cars, I'm going to change lanes. They'll part for them, open up, and we won't get 40,000 deaths a year, as we currently do from automobile accidents. We can determine the mass of the black hole by how fast stars are moving at the distance they are from it. So in other words, we're Earth orbiting the sun, and we have a certain speed. We're going about 18 miles per second. I think that's the number, 30 kilometers a second. That's our speed around the sun. That's pretty fast, okay? If the sun had more mass instantly, that speed is not enough to maintain our orbit, and we'll start spiraling in towards it. If the sun had less mass, it's too fast to maintain this orbit. It'll climb us out to a higher orbit, slow us down, and we'll be in a higher orbit with a slower speed. For any object, at any distance, there's only one speed you can maintain and have a stable orbit around it. So when we see stars orbiting something in the center of the galaxy, it is a straightforward Astro 102 equation to calculate how much mass the thing is orbiting. And you get the mass, and you can't see it. It's small. It's a black hole.